Good evening, everyone. Welcome back to fourth day of the online faculty development program on future innovations, energy and sustainability. We now look forward to another insightful day of knowledge, sharing and discourse. We are pleased to welcome our resource person for this session, Dr. D.V. Rajan sir from Damodar Valley Corporation, Kolkata. A warm welcome to you, sir. Dr. Rajan has been associated with Damodar Valley Corporation since 1994 and currently serves as a Chief General Manager. He brings over 30 years of industrial experience in R&D, erection, commissioning, and operations and maintenance of thermal power generation systems. Sir has made significant contributions through national and international publications in the domains of power system, electrical engineering, and energy research. His current research interests include power flow techniques, state estimation, power system operation and planning, grid integration of renewable energy resources, and the application of soft computing techniques in energy systems, engineering systems. We are honored to have you with us, sir, and request you to kindly take over the session. Thank you.
Thank you, ma'am. Good evening to all. Before starting, just I want to convey my heartfelt thanks to the total NIT, National Institute of Technology, Durgapur, Department of Electrical Engineering, head of the department, as well as the coordinator of this total program, Dr. Bhattacharya and Dr. Baumik sir, and all other eminent faculty members. And also all the participants and all the professors who are joined today's session. Before starting my talk on this today's relevant topic, I want to share my presentation. Just is it visible? Is it visible, sir?
Yes, sir. Yes, sir. It's visible.
So now. So once again, welcome to all. And my topic, what I already told, is the Indian power scenario and energy transition issues and challenges. This is the topic on which I want to just give some of the important points, what I gathered, what I learned, and what I want to collect from you also on today's session. And since it is a faculty development program, whatever the message that I have received, and it is my once again, it is my really pleasure to have this session today with all of you. My outline of the presentation is like this: present scenario, key growth points, scaling of RE in India, energy mix, energy transition and ensuring energy security, operational excellence, challenges and flexible operation. Mainly, this is the hot topic today. That I want to go some of the deliberations across this presentation. Before starting my presentation, am I audible now? Hello?
Sir, yes, sir. Yes, sir. You are audible.
Okay. Now, before starting of my presentation, I want to just give the ex-president's message, power independence, cut down the energy losses, utilize technologies to provide a diverse supply of environmentally friendly energy. We must achieve energy independence by 2030, including a cut down in all sectors, increase the power generated through renewable energy sources. With this, I want to just give in a very fast manner because as we all are know that electricity is a basic human need and economic indicator, and it is a critical infrastructure on which the socio-economic development of the country depends. Now, if we come to our total power as on date, power capacity, installed capacity is 4,75,212 megawatt. out of which we are having total thermal renewables, in which hydro, wind, and solar will come. Apart from that, in the coal also, there is lignite and adding to gas. Apart from this, we are having a nuclear also. That breakup I want to show here. Actually, coal, lignite, gas, diesel comes under fossil fuel. That is, our percentage is 48.87 percentage of the total installed capacity. And non-fossil, that means clean power, nuclear, large hydro, and renewable energy sources comes around 39.37%, and it adds to today's installed capacity. Now, coming to major share of the total this installed capacity is coal, because this is 43.41%. 2 lakh, we have already touched 2 lakh 17,458 megawatt. Now, if we come down to just like renewable, breakdown of the renewable energy is like this: solar, wind, as I already told, biomass cogeneration, and small hydro, waste to energy. So these are the some of the segments which comes under renewable energy. Is already we crossed 125 megawatt of solar, and wind power is 53,000 megawatt, and okay, biomass is a little bit less, that is 10,757 megawatt. Small hydro is 5,133 megawatt. And the very interesting area where we have to address, and also already we are addressing, that is waste to energy. It is a need of the day. That importance also I will cover during my presentation. This is around 854 megawatt as on date. Now, as in a at a glance, if you can visualize how the power is generating, and we are now enjoying by sitting in the house, what is the level, at what level we are receiving, and what level it is generating. It is really a very good picture. Here I want to put it in front of you. That is power generating station. And normally in power generating station, as on date, in up to 500 megawatt, it is 210 megawatt is 12.75 kV, and that 500 megawatt is 21 kV generating voltage. Now, but how we are getting a 230 volt in our domestic supply for our households? It is just like a network which is consisting of three parts. One is generation, transmission, and distribution. Now, after the generation, we are using the step-up transformers to our voltage level, to which we want, and it is already we have touched 1200 kV line in India also, and 765 kV line, as well as 400 kV network also. After that, we want to reduce the voltage secondary transmission, that is step down by using the step down transformer, and it will ultimately come to primary distribution, and that is the three-phase distribution, and normally that is 450 volt. When it comes to our households, it is phase to neutral, that will come to 220 volt. This is the total small distribution total electricity as on date. Now, with this 4 lakh megawatt installed capacity, our transmission network is also very much essential to make it very sustainable, as well as very strong and reliable also, because it is a media where we want to transmit the power. So in this area also, we can here now I am showing this slide. This one is normally what happened. This is in 2015-16. If you can see, 3,41,551 circuit kilometers, whereas we are now achieving more than this 50,000. This is the transmission network through tower transmission lines. We are expanding in this fashion. Now, as we have seen, India met with a peak demand of 239.6 gigawatt at 9:56 hours. This is the data on 30th December 2025. This means our peak demand already touched 239 gigawatt, and system frequency, that is very important factor, where we are all know that is the band is in between 49.9 to 50.05, and on that day total energy consumption at this moment is 4,662 million units, out of which, again, because now very interesting figure is renewables, because how we can address the clean, green, sustainable energy. That's why solar generation out on that day, particularly 30th December, it comes to 470 million units, and wind generation is 52 million units. This is the one recorded figures on what we have achieved on 30th December. Now, from this, we can record peak is 250 gigawatt, which is every year we are achieving more and more. That means our growth is also, power sector growth is increasing. Why? Because demand is there and need of the day also is there. Now growth is also 33%, and mainly who are the drivers? Rising AC loads, heat waves, industrial and commercial expansion, and EV adoption are key factors. These are all the key factors which are actually increasing the power demand. Now, as we know that our load demand curve is very important for any of our power engineers. So, suppose if we can see the morning peak and evening peak. Earlier, we used to follow what will be the morning peak and what will be the evening peak, because at that time it is required for load pattern estimation. But now another two factors came: night lean and day lean. This is also very important, because growth is so high. We have to meet up at the same time. Accountability is also increases. Fossil fuel we want to reduce, and we want to just introducing our renewable energy as much as we can. Means morning peak and evening peak is even though very important, at the same time night lean and day lean is also important. So if you can see this figure, whatever I have just thrown on the screen, here we can understand this is the time hours, 24 slots, where night lean is 4 o'clock and day lean is 1 o'clock. See, now we can, if we can know the load pattern, accordingly planning is very important. And at the same time, scheduling is also very important. Means for planning and scheduling of any power requirement, we have to know what is the load pattern of that particular area, as well as what are the upcoming industries, and whether we can substantiate those things or not, and we can encourage to get more and more of renewable energy. Now, coming to strong growth drivers for the power sector in India is mainly demand and supply. Means our GDP is expected to grow significantly, and India has low power capita consumption of electricity, which is expected to rise 3,000 kilowatt hour by 2040. This is one of the indicators that we know. Now, coming to the supply, electricity requirement is expected to growth, as well as both peak load demand energy requirement expected to rise the very fast manner. So keeping all these two, we can have the picture, projecting picture is 3,000 kilowatt hour per year, and energy requirement is also increasing. This is the financial year I have shown here. Okay. Now coming to this one. Now India's energy sector is if we can divide in two things, in two manners. One is fossil energy and another one is renewable energy. Okay, now awareness is increased and resources are available, and technology is also advancing, enhancing, and research is also big blip is going on. So keeping all these things, we can mix our requirement in such a fashion that we want to reduce use of fossil energy as well as we want to increase the renewable energy as much as we can. Now coming to India, since our country is rich of all the things, it is combination of all fossil fuel and renewables also. And geographical point of view, location point of view, we have to go for our requirement, and we can identify some of the things where we can means as we already have our footprint in coal generation. And okay, I will give the some of the figures of nuclear. That is the why it is so less. And whereas we are having blessed by our hydel energy, but on the other hand, we are coming up with a big way of renewable, in which the wind and solar, not only wind and solar, micro hydel. At the same time, we are also adding biomass and other energy resources. Coming to, for every country, as we know, the energy mix is the prime factor where we have to have our energy mix in a good proposition. Means if we know the solar, wind, hydro, geothermal, biomass, nuclear, gas is our availability. And the energy mix is one of the important factor for any country. So coming to the latest figure, that is nuclear, hydro, thermal, and renewable. In thermal, I have already added that coal, lignite, and all gas. Now coming to this total figure is already projected is 5,01,688 megawatt, in which thermal is 2,45,000 megawatt. Okay, but coming to other figures, we are already running in the same phase with renewables also. Hydro is some of the little bit constraints are there, but we are trying our level best to bring in another fashion, that is the PSP. That is the latest requirement, advanced technology advancement as well as requirement also. And also it is a promising nuclear, even though it is very less, but future is also we have to addressing some of the nuclear power plants upcoming in our country. Now coming to the Indian, as we know, Indian power system is a complex network and is going at a rapid pace. Now coming to our transmission system, it is a really very, very complex and critical one of the power system network. And as we know that our total power system is operating on one nation, one grid, and one frequency. This is our dictum, and we are following, and we have to obey, and we are also achieving the total system stability as well as reliability and security. Now, coming to the total transmission network, as I already shown, the transmission is only possible through the transmission network. Here, we have already achieved 765 kV lines, 400 kV, 220 kV, and I am not at all considering the 132 kV, which is very more in number, but we have to concentrate the things in a big manner. 1200 kV is also we have operating in our country. So if we can see the satellite picture, it looks like this. And here, why I am showing this slide is this much of the progress where we are already. Apart from that, high voltage DC line. This is why it is required, as we know. And bulk power transmission is required through HVDC can only be one thing where we can address, and that also we are operating in our daily power system network. Coming to satellite picture, as I told, 132 kV, it is really just like a mesh. So by operating all different voltage levels is really great challenge for any power engineer, rather electrical engineer in our country. So we shall feel proud also. Now coming to how it is possible. And where it is our total control is going on, how we are achieved this reliable supply. If we can go back to 1950s, there are local energy centers, ECCs. Gradually, we have come to state. And then in 1970s, the work is going on that we have already addressed regional load dispatch centers. Now, it is really 1990s that it took start to national grid. So this is the evolution of the grid. Now, as we know, we are operating in 5 grids earlier in 1991. After that, we have synchronized east and northeast. And it is really this transformation or metamorphosis of grid is so far is seen is really amazing and also very surprising that today we are operating one frequency post at 2030. Means it is a research work of at least 20 years gradual working on the grid integration. So ultimately, what happened? We have to we are now on the in a position that we are operating in one grid. Means one grid, one frequency, one nation. So when why it is, what are the advantages? Why it is so neat? So if we can compare to this total grid, we are having, as I told, North, NR, SR, Southern region, Western region, as well as ER and Northeast. When we are already added all these things, what are the advantages? Why we have added and what are the things? Now, little just there is a correction. SLDC, state load dispatch centers, is 33 instead of 31. Whatever I am showing here is 33. It should be 33. And 5 is regional load dispatch centers, and 1 is the national load dispatch center. It is the apex body to ensure integrate and operation of the national power supply. And what are the advantages? Why it is required? Because, as we know, strong backbone, anywhere to anywhere, and economic operation, optimal utilization of scarce national resources, added stability, boundary-less operation. So with the backdrop of with these 5 things, we are in a position that today we are operating total power station network through national grid, and also it is very proud to convey to we are operating from Haryana in our eastern region, where we are located in eastern part. We are operating the total isolators and breakers by city. Suppose I am telling an example in Durgapur. We are operating the isolator and breakers by controlling from the Patna, that is regional load dispatch center. From there, they are able to control this much of the things that we are already achieved, and we want to continue in future also. Coming to, before going to further, I want to give some of the small information. What is the past and what is the present? See, today what we are what we are enjoying. Before, prior to that, if you can see, electric light first came into India in Calcutta on 24th of July 1879. This is the one of the historical events, some of the historical events. And first hydroelectric installation is Sidrapong of Darjeeling municipality. Okay. Next, hydroelectric power station is Jammu Kashmir. So it was came into 1905. And one first company generating station, BST company, is established, and it is given to supply to tramway. And first electric train run between Bombay's Victoria terminus to Kurla along the harbour line. Why I am showing this one? Because last is very, very important. First train we have only run between the 2 stations, Bombay Victoria terminus and Kurla. Today, our total railway network is through already electrified, and that also I will show the total data where how much we have achieved. And coming to the few of the glimpses that I want to throw you. This is the Hydel power station. Looks like this. And the first electric train is what I told is this. And first is thermal power station came in Hyderabad. That is in the year 1920. That capacity 22.5 megawatt. But now we have achieved 2 lakh plus megawatt installed capacity of thermal. So this is the journey where just 1920 to 2025. Now, Tarapur Atomic Power Plant, first is 1963. We come up with 1400 megawatt. Now, if we can compare this figure in 1963 to till date, we have already achieved 8,000 megawatt, means almost 6 times, 6 folds we have increased in the nuclear. Now, coming to the progress growth. So, if we can compare anything with the things what we are now as on date is that gigawatt we already achieved in August 229, and December figure I have given to you. And fossil fuel is also 49% and 500 gigawatt as on September 2025. Coming to non-fossil fuel sources is 51%, and India's all-time peak. It is why I am showing again the August figure, because we already crossed 229 gigawatt in month of December. That's why I have given emphasis on this 229 gigawatt. Now, coming to the transmission voltage network, how the transformations occur and where we are standing as on date. If you can see 1977, 220 kV is the one of the highest voltage that we have operated. At that time, we are operating even less than that, 132 kV. And that's why 130 kV line, kV transmission network is very clumsy and very big in size. Now coming to when 220 kV we are operating, we feel something okay, 220 kV is only possible. But if we can see this from this graph, it is evident that we are already entered to 1200 kV, which is world highest voltage level. And also that is NHPTL, National High Voltage Testing Laboratory, Bina line, that is 1200 kV line we are operating. 765 kV this, double circuit line is also there. 800 kV, as I told, HVDC is also very important. 800 kV line, and we are operating. Whereas 765 kV voltage lines also we are coming. Why it is required? And what are the things, advantages that, since as we are all know that I don't want to take much of time on this one. And coming to this energy mix, capacity mix and all, even though in thermal 240, I can add here some of the things, solar, bio, small hydro and wind power, nuclear and hydro comes to renewable, whereas thermal is 240. Now, everything is like dictum. Whenever the dictum came that renewable energy and clean green energy, then we also stand forward in front of our country's commitment, and already we have achieved renewable energy and 8.8 gigawatt of nuclear power. See, this is the area where we have only 1400 megawatt. Now, as on date, we have already arrived at 8 gigawatt. Now, this makes a significant step towards India's decarbonization goals and its pledge to a sustainable future. This is the dictum that we have to follow, and we are also following. We have to, we will try our level best to more and more. And what is the difference between clean energy, renewable energy, and green energy? As we are already, so many persons will tell, we have clean energy, the green energy, and RE, renewable energy. So this is a small slide I want to throw in front of you. It is nothing but clean energy is any source that does not emit greenhouse gases like nuclear power. But renewable energy comes from the sources that naturally replenish, such as hydropower and biogas. Whereas green energy goes to a step further. It is both renewable and environmentally friendly, like solar, wind, geothermal, and low impact hydro. So these are the things. That's why I have made it clear with a color coding also. This is a small information what I want to just present in front of you. Coming to the growth statistics, as I already shown, 2014, if we can compare with 2025. Hello, am I audible? Hello? Hello?
Yes, sir, you are audible, sir.
So if we can, yeah, if we can compare with, if we can compare, If you can compare with the 2014, this is the big jump, that is 76 gigawatt to 227. Now coming to the renewables, that is also from 17.2 to 22%. This is the really great increase in the addition of the RE. Apart from that, manufacturing boost. This is also this is also there. That's why we have to cope up with the generation. At the same time, I want to just throw this hydropower expansion is also from 35.8 gigawatt to 48 gigawatt, 14 to 25, means targeting 55 gigawatt by 2030. So these are the generation figures that we need to address. Now, coming to the other domain, that is wind energy, which is estimated in the country is 1164 gigawatt at 150 meters above ground, whereas India wind energy achievements are really the great figures. That is, as on date, electric generation by wind energy rose to 78.21 billion units between April 24 to February 25, contributing 4.69% of electrical generation. LCT generation, in totality, it is sharing is approximately 5%. Domestic manufacturing strengthened, that is 31 certified wind turbine models being manufactured by 14 Indian companies. I am repeating once again, the 14 Indian companies are able to manufacture the turbine models as well as 18 gigawatt annual manufacturing capacity. So this is also one of the things that we have to see. Now coming to the this one sun and one world. Again, Prime Minister of India first assembly in the International Alliances ISA October 2018 had called One Sun One World, OSOWOG, and one grid. It is a global initiative to create a transnational power grid based on the idea that the sun never sleeps, and International Solar Alliance is the leading its implementation. So a task force is also already working on this one, and we are also one of the members in the total task force. Now coming to biopower, see, this is another area where 8.1 gigawatt initially we have arrived to 11.6 gigawatt. So why it is required? Because every from the waste to energy, this is the one of the interesting area that I already initially I told. We are also working in the largest sphere in this area, and every big cities and every municipality we have to make awareness of this waste to energy projects and pipelines, so that it will give a good image to the society also. And it can be possible in urban, industrial, and agricultural waste to energy program. Biomass program is really it is supported to the pellets, torrefied and non-torrefied, which is made out of this biomass. And one of the interesting project that what we have did is we have used this one grass with 1 minute. Grass, leaves, grass and leaves. And apart from that, we want to add some of the things like straw grass, so that it will, we manufactured that one, we prepared pellets, and we are tested in even this GCV also, calorific value also. And even though if we can mix with the normal coal firing of the plants in where we can reduce the environmental pollution, as well as we can use this waste products. And biogas program is also one of the thing in which we have taken a project of this pilot project with NIT Jamshedpur, where that hostel, 10,000 capacity hostel, we have developed one model in pilot scale, and where the whatever the gas is we are achieving, we can reuse for the canteen purpose. Similarly, in a higher scale model, we want to just develop the same thing in our one of the merchant unit, DVC Damodar Corporation, MTPS, Major Thermal Power Station, where labor is very labor intensified canteen is there, and every day we are 400 to 500 workers will take, so that with the waste we can food waste we can turn it to biogas plant. Now coming to some of the 31st cumulative installed capacity of all these things, 9.8 gigawatt. And also one of the things that I want to just highlight here, 51.04 lakh small and 361 medium with cumulative 11.5 megawatt off-grid power generation capacity. So now coming to off-grid and on-grid. Later I will cover this on-grid and off-grid. And some of the things in nuclear are already told. That is also a very promising figure, 35,592 to 56,681 million units, and 71% rise in the installed capacity of the nuclear. We are already achieved, and some of the projects is under proposal. So this is taken care by NPCIL, National Nuclear Power Corporation of India Limited. Now, coming to the new reactors commissioned, as I already told, we are coming up with additional nuclear power domain, where this is the 1,000 megawatt, that is the Kudankulam, and also we are coming up with the Kakrapar atomic power station. Rajasthan is also having unit 700 megawatt, which is to be supposed to be 2025. Now, apart from this, the another way where we are addressing the green hydrogen mission. This is also very, very important. That green hydrogen mission we are running with in a big phase, and also we are coming with a good manner way. Why it is required? Because fertilizer industry, hydrogen is one of the thing. Ammonia is one of the key element where it is required. And if we can add hydrogen, that is you can call it as a green fertilizers also. So fertilizer industry, where it is very near to the thermal power plants, we are also having our own MOU with fertilizer industries also. Now, in overall, if you can see up to 132 32 kV Indian power system, we are having some of the total news, northeast, west news, 1,279 missions with 852 branches and 1,855 transformers of different ratings. Bus reactors are 167 and line reactors are 379. The importance of the total power system is very, very important, very, very interesting to know about the reactors and the line reactors and bus reactors, and also number of branches. We have to take into consideration while calculating the load flow analysis and all other things. Coming to, as I told, 765 kV lines, we are having 7,576. 13 figure, but now we have double already, 50,000. Hello?
Yes, you are audible.
So now, yes, sir. Now coming to some of the challenges, where actually we have to pay our attention, and what are the big challenges that we are facing and we are going to face and we will face in future also. Those are, as because of the total power system, when it has been trifurcated into three sectors: Genco, Transco, and Discoms. Generating companies, transmission companies, and distribution companies. Because of the low end, distribution companies are there. Because their healthiness is not so healthy, poor financial state Discoms, the domestic coal suppliers.
ये वाला फुटबॉल इसमें देखता है
Hello. the domestic coal supplies and imported coal dependency, transmission and distribution infrastructure inadequacy, and integration of thermal and RE. These are the two challenges that we are facing. And also, hello, sir, some of the someone are on mute, kindly, sir.
Yes, others, please mute yourself.
Okay, sir. Now, these are the few challenges. And coming to the total, apart from the challenges, we are having some ATN losses. That also we are trying our level best. We have already achieved all India average is 15 to 16%. Even we have to try further. Earlier it was in a big volume, but now it come down to 15 to 16%. And since work is going on, we may also go for another some of the percentage reduction in this figure. And carbon emission, as we know that the greenhouse is the main target. So when the thermal power plants are one of the main source for this pollution and carbon emission, so we are coming up with latest technologies where we are achieving even 20 milligrams per normal meter cube. This is the pollution norms which are bind with us. Even in abroad, foreign countries, they are maintaining at single figure less than 5 milligrams per normal meter cube SPM. So now that means once it is possible, means we have to try and we have to work out thoroughly, and we are also working where the emission levels we are brought down to even less than 20. And this is the figure where we can have our CO2 emissions projection. Now coming to renewable energy, solar and wind are intermittent. Actually, this wind and solar, if you can see, when we can have our duct curve where the crest and troughs are there. Now, whereas solar is solar output as well as the mean forecast of solar output. If you can plot in one figure, it is just like a renewable energy intermittent pattern. Now, even though we know all generations are possible and we are achieving and we are also meeting our targets and goals, but what is the behind that? Behind is CBM technology, condition-based maintenance technology. For any electrical equipment, maintenance is very, very important, especially in power system network. Even though generation is generator, that is we know, but in transmission network, it is the totally weakest part. Because whenever there is a link, means that is the weakest part. Means we are having a number of we are having a number of elements like isolators, circuit breakers, and connectors, so many things. So we have to maintain periodic, very, very meticulously, and otherwise we can increase the breakdown. So the CBM is one of the technology where we can reduce our total maintenance. So now, by doing this, what we can avoid? Just I want to show you this. Sharing one video. Are you? So now, what is this? This is 765 kV switchyard where isolators are auto operated, and even though what is the harm if it is stuck or if it is having some technically some fault, what can be done, what can happen? So for which we have to take preventive maintenance, predictive maintenance, even breakdown maintenance. Apart from that, in totality, it is a condition CBM technology where we can give the total things in a good manner. Once again, just this is the opening, opening of isolator. This is the it is isolator cannot be operated on load condition. It can be operated on only offload condition, where even though it is offload condition and the spark is somehow less, but when it is coming to close to contact or when it is opening from the contact, homing up the contacts is very, very important, as we know. But the operation point of view, if I can, 1 second, I'm just opening the contacts. See, this much of the. So this is the intensity of this total. Yeah. Now, just 1 minute. So this is one thing. Then next second is what we can avoid. That what I want to mean is proper maintenance and monitoring of the electrical equipment is very, very important. If we can know, because in electrical especially, we won't get any time. Suppose for a transformer, if any parameter is violating or any symptom what we have observed, we cannot deny, we cannot ignore, and we cannot keep it as it is, because it may create a devastation like this. Just I want to show you one transformer of 1500 kVA, 1500 kVA, only 1.5 MVA. This is the total by ignoring the things, some of the parameters, this will be the end effect. So we can avoid by proper monitoring and maintenance. Now coming to tower, transmission lines, because it is as I told, this tower, by seeing this tower, this is for 400 kV transmission line in quad moves. 4 number of conductors are there, and before that, if anything may happen. But prior to that, testing is very, very important, and especially insulators. If anything we ignore, then the effect is like this. Just to see the effect. No problem, it is going on. But so this is the so this is the one of the things that we have to take care. And coming to the other now latest trends in the sustainable energy sector, that is battery energy storage, BESS. As we know, these are the things where we can store our energy. Why it is required? Because as we know, our load pattern is nowadays is totally changed, and when there is a demand, we have to give power to the consumers, as well as when there is a surplus of power, we have to preserve also. Earlier, the concept was demand and supply is almost very in another place, whereas now everything is changing. Commercial aspects are changed, regulations are changed, and industrialization is going on. So many things are coming up with to meet the demand. Means day and night equally we have to operate, because when the power demand will come, when the power surplus will come, we cannot predict. But thing is that we can have surplus power in reserve, like in idle power plants are black start. For black start, we have to use earlier we are using idle, but nowadays it is also not required. Even we don't want to depend upon the idle black start, whereas we can have our own battery energy storage also, so that startup power we can get from these sources. So one of the important thing is that battery energy storage is very playing very important role in today's energy storage systems, and it is mainly used for electric vehicles, solar power installations, and smart homes. because now every need and necessity every day is changing. So to meet up our requirement, we have to get the things ready-made. So battery energy storage systems is one of the element where it will support to the grid. So there are so many types of BESS, battery energy storage systems, but the transformations also I just want to show you. Lithium ion is earlier, but lithium silicon is coming up with, and another is lead acid batteries and flow batteries. Why batteries are very, very important? As we know, DC is very reliable and um, very much essential also. So for all control systems, we are depending upon the DC system because it will give very stable. Now, apart from that, flywheel is also there. We can accelerating a rotor to speed up the electrical power generation, storing energy also. These are the types of BESS. And what are the types of things? Residential, small, and commercial. So residential small batteries that we know, and battery energy storage for business and multi-family family housings is small category, comes under small category, whereas in the commercial industry battery storage is bigger one. In power generating stations, we are having a 220 volt DC battery system. Is dedicatedly, one is working, one is standby. Means one bank is at of 220, 110 volts, 110 cells, 220 volts. So of the same capacity of another, which will work on the standby mode. So if we can see the total supply, residential scale battery, that is even less than 30 kilowatt hour. This is the one of the things that they are supplying this Powerwall Tesla, and is allowed by right as an accessory to use all the districts. Now coming to the 10 megawatt hours battery energy storage systems. This is volume is, even though volume is bigger, but reliable is more, and it is also even aggregate energy greater than 30 kilowatt hour to 10 megawatt hours. The small scale energy storage systems is also now we are already installed. And whereas where it is required for business districts and overall district through the granting a special permit for the community development board. This is the application. Whereas in commercial and industrial scale, which actually it is a role is very, very important to, it will give supplement to the grid stability, because grid is operating on grid operation is totally dynamic. As and when required, we cannot operate as we want, but grid operation supplement is required and standby is required, where we can achieve from this battery energy storage systems. And as on date, this commercial and industrial scale battery energy storage systems are permitted as a principal or accessory use only in the granting special permit from the community development board. These are the things where we are also encouraging, and we are coming up with a battery energy storage systems to support our operation of the grid. Coming to pump hydro energy storage, PHES. These are the things where it is very not latest technology, but the use of resources in a proper manner and to address the critical issues. Since frequency is the one of the factor where we have to maintain our grid discipline and grid code and all, whenever there is a lean, we can pump the water to upper valley, upper reservoir, and through penstock, through passing through the powerhouse, we can have our own generation, keeping all the other things in the PSB. So this is one of the things where we are also coming up with. And in India, we are having even number of units, and total details I will show you. But here the main technicalities we can consider, there are upper reservoir and lower reservoir connected through the penstock, and in between upper valley and lower reservoir, This powerhouse we will install so that at time of requirement, we can generate a power so that it will give supplement or reliability. It will enhance reliability of the grid also. Now coming to the kinetic energy of the falling water turns to a turbine, and turbine turns a generator. Normally, as we know, in thermal also, turbine, a steam turbine is coupled to generator, and the generator ultimately will generate, and it will power will go to the transformer or to enhance the voltage. Like this only here also, generator converts mechanical energy to electrical energy. This is the transformation of energy, as we know. So now coming to the total important parts, and first PHES introduced it in Italy in 1890. And the main parts are turbine, generator, motor, and pump. Why? Because turbine, generator, motor is there, but now pump is also there. Pump means again the water is required to send it to the upper valley. Through pump we will use. But again there is a big interesting parameter, frequency and demand. So accordingly we have to operate our pump. So if you can see the look of any PHES, this looks like this. And it is one of the examples that I want to show you here is 230 feet head and 6 billion feet cube of water and 29 megawatt of generating power. In India, we are having in West Bengal West Bengal State Electricity Distribution Company. There we are having a pump storage unit also. Normally, the operation is very similar. This is nothing but power is given by the product of effort and this one force. So this is the application. But now, why I want to show you this? It will help to meet the load during peak hours and storage energy during off-peak hours. These are the two things where we can have our own control. Also, it will frequency regulation also it will help, and voltage support also, reactive power flow control to help maintain desired grid voltage. Because nowadays grid code and ISG's grid code and grid operation is very, very important, where the voltage variation is very, very less, and we have to maintain. Otherwise, it will they will not allow. So for which we can use this one, like synchronous condenser in earlier, that is also there. Like that only we can use PHES also into our system. And as we know, black stack capability. Now I'm really proud. In DVC we are having a Methane power station idle. That is a black startup facility is there. So when the grid failure is occurs, immediately for startup power, it is required to start any of the idle unit is very easy. But for starting the idle unit also, some of the plants are identified across the country. One among which is the Methane. It will we can just opening the gates, we can come to power generation, and we can gradually establish our total network, and also spinning reservoir. Coming to these are the other operations: open loop and closed loop. And since I told the main important parts are generator, turbine, motor, and pump. So how they are coupled? They are coupling on the same base. Generator is coupled to turbine, motor, and pump. Now, if you can see this graph, the flow meters, accordingly the head will be, according to the head, flow will be, we can establish, and this is the various turbines, Francis turbine, Kaplan turbine, as we know, accordingly we can design. This is the design parameter where I want to show Pelton and Francis, 1000 megawatt. So this is the picture is like this. This is the Francis turbine. This is the another thing. This is the Pelton turbine, and according to the flow. Now, coming to the variable speed operation with synchronous motor generator is also the same thing. Whatever we know, that is nothing but three-phase AC supply we will get, and motor or generator through field excitation it will start. as well as it will ultimately give to them. Now coming to frequency regulation, this is also very important. And what are the losses? Everywhere, whenever I told closed loop and open loop, there will be losses. So here pumping, even though this typical losses in pump storage generator stations, penstock pump motor transformer comes to approximately 12%, whereas in generating side it is very less. So total efficiency of this PHES is 86.8%. Now renewable energy potential, as we know that already I told, we are having a good energy mix: wind, solar, and biomass, and small hydro. So the figures are collected from our energy source magazine. This is 302 gigawatts, and solar is 750 gigawatt, in which we have already crossed 175 gigawatt. Biomass is 25 gigawatt, and solar small hydro is 20 gigawatt. Now coming to wind, as we are having India is a wind atlas, upon which we can know the wind. Hello, so someone is the.
Dr. Jayanta Kumar, please mute yourself.
Yes,
Dr.
sir.
Jayanta Kumar, Jayanta Kumar, please mute yourself. Jayanta Kumar, hello. Hello, Jayanta Kumar, please mute yourself.
Okay, sir, I will continue because my time is running short. So coming to wind energy, we are having wind energy potential, and wind energy, the world's fastest growing energy source, is clean and renewable source of energy that I already conveyed. And this world wind is one of the cheapest and cleanest energy source. So at the end of the day, the energy should be clean and cheap. That will be the power to all, affordable power to all. Power to all is we have achieved, but affordable power is very important. Where the commercial aspect will come, it means cheapest power is required. At the same time, cleanest power is also required, because as we are addressing to the society as a human being, we want to have a good health. So these are the two terms: cheapest and cleanest energy is required for every country, every human being. So coming to total wind machines history, earlier it was started in 17th century, even though, but now we are having a three horizontal axis, vertical axis. So if we can see, hello. Now coming to some of the things that I want to show. Wind energy companies as on date is Suzlon, Inox Wind, JSW, Adani, Tata, and NTPC. We coming with wind energy capacity, as well as they're adding the value to the total power system, today's power system. And as we know that advantages and disadvantages, even though we no need to mechanism, whereas some of the things are very important, and it is connected to the radial. So if anything will happen, we have to take the maintenances also. This is some of the old-fashioned windmills. And coming to the wind turbine use, electricity for homes and farms, electricity for communities, industry, as well as supplying electricity for a nation, remote communities, energy to drive pumps. These are the applications where wind turbines we are using. Just I'm going little bit faster. These are some of the things that is not very important. But thing is that they are having environmental aesthetic look, as well as birds and other living resources. It is very important that some of the things we have to take care. But we, in unavoidable circumstances, we cannot do. Anyhow, some of the things like birds will affect with the wind turbines, whereas noise, like all mechanical system, wind turbines produces small, very less noise. And whereas global warming, wind energy can help fight global warming. Wind turbine product no air emissions or greenhouse gases. This is some of the advantages. And what are the economics? Economics is of the wind energy based on the wind source, capital cost, wind energy market, and technology. So keeping all these things, we are having our own wind atlas across the country, so that if it is possible or not, viable or not, we have to take a decision. So that's why we won't find any of the windmills in this part because of the potential, available potential. Whereas in western part, we are having a good number of windmills. Now, it will, why it is, because the electrical utility cost is already reduced to 80% for the last 20 years. If you can see the utility scale wind systems, we have dropped, even drastically it has dropped. And in cost point of view, it is very, very important to know the things like, if we in 1981, 25 kilowatt, costing about this per kilowatt is $2,600, whereas in 2000 it come down to 1/3, 790. This is the cost comparison, so that one can and coming to the traditional fuel options and renewable options, we are having our compared energy resources, and it is just I want to show some of the things. So now what we can conclude is that true that today's world need more clean and cheap power, cheap energy. Wind energy is one of the best way to achieve these two factors, and future most of our energy will be based on the wind energy. Now, growth-wise, if you can see, this is the trend where we have already reached. So this is in megawatt, and it is in state-wise. As I told, there are, even though it is not possible to go for wind energy, but we are having our some information from Wind Atlas, Andhra Pradesh, Gujarat, Karnataka, and other Rajasthan. They are having a good potential. So we are already achieved this 4,000 megawatt in Rajasthan, whereas in Gujarat I told 4,000. So coming to the quality assurance center, this is important. And evaluation. This is the one of the thing where 900 kilowatt rated power we have in 2001 started, whereas now we are having 3,000 kilowatt wind turbine design we have already achieved. So there are some of the institutes where we can have our own research R&D activities, and tariff, you can compare the tariff also. It is even less than, apart from the Rajasthan, it is less than even 4 rupees 15 paise per 1 kilowatt hour, 1 unit generating cost. Even if it is, we may reduce also further. And these are the future plans. And some of the major challenges. Just I want to add this waste to energy. One of the interesting aspect where waste we can add to our turn to energy. Okay. Now coming to as there is, sir, there is maybe Dr. Pragati Kumar, sir. Any doubt is there, sir? Please. Hello. Hello.
Dr. Pragati Kumar, please, if you have any doubt, you can please proceed. Otherwise, mute yourself. Dr. Pragati Kumar, it's my earnest request to please mute yourself.
Okay, sir. I will take up the call. Next is coming to this waste to energy, bio, CNG, and organic fertilizers. These are the things where the one biogas plant cost is around 3 crores. Payback period is only 2.90. This is the very interesting, as well as we can add some of our footprints to the society also. This is the one of the things that they have taken in Bhopal. And this is the captive waste to energy plant. And some of the thing, just I want to skip this video. I will show you afterwards. This is the overall view of the waste to energy plant and nuclear power plant, as I already told. And coming to very interesting rooftop wind and solar hybrid system. This is one of the things where we can have our own models, because this is the one of the complete solution we will get from rooftop wind and solar hybrid. This is the hybrid network. Now coming to the total top 10 solar modules. This is the total manufacturing by future capacity. This one, Reliance, our Indian companies, as I already told, so many companies are already manufacturing the total solar modules. Means indirectly we are not depending upon the foreign products. Now coming to some of the pictures I want to show you. Before that, the solar rooftop systems connected to the grid. This is the state-wise PV module cell manufacturing capacity. See how the total solar cell PV modules and cells are manufacturing across India. This is the total picture. And coming to the evolution of solar site, earlier we are having only M2 solar panel, where 100 by 100 size. Where now it is come to G12 22 present is now it is having a one is high power and fuel cells lower cost per watt. This is the total evolution. And coming to the some of the important installations of PV solar, ground mounted and rooftop are like this. And this is the one of the thing where the plant capacity is 115 DMRC, Anand Vihar Pragati Maidan. And these are the some of the things where one of the Delhi installations. And even I am very proud to tell that NIT Durgapur is also having their own rooftop solar also. And in our DVC Towers also, everywhere, every building. Nowadays, they are making some of the good, interesting exemptions and all, so that one will act as a generator. So this is the 360 kilowatt peak. This is the Chennai. This is our auto forging. Even though ventilation fans are there, exhaust fans are there, apart from that, by utilization of space in meticulously, we can achieve our target. So these are the few. Now, interesting is one of the city, that is Chandigarh. They have addressed it to the nation of the 1 megawatt rooftop plant in one location. And it is again Chandigarh, and it is a government college, 495 kilowatt rooftop. And this is the journey of the solar across the India. Now coming to battery energy, BESS also I told, this is also a complete solution. And now this is a very interesting figure where I want to just add railway electrification. We have already achieved 99.2% our rail network by electricity. This is also we are second in number in the across the world. Now this biomass, as I told, pellets, and by using the waste of straw and other bonding material like this mustard, all these things we want to we want to come up with the pellets. Both the things are there. Torrefied and non-torrefied. Torrefied is a little bit costlier, but non-torrefied is cheaper. So that we can, even though the GCV is less, we can mix with normal washed coal, so that we can use and we can meaningful utilization of this total waste. Now, as we know that these are the straw dusters also we can use. And this, as I told, biomass anaerobic digestion, biogas digester. This is the food waste pilot project. We can have our own here. Then biofuels, ethanol, and everything is coming up. Now coming to this one. These are some of the floating solar. As another one more interesting is floating solar. This is 4 megawatt peak DC. This is the installed over rivers, And now we are having our own idle in Damodar Valley Corporation. We are having our own dams. On dams only, we are going for the floating solar also. Like that, floating solar is upcoming big leap. It is coming in the power generation also. And 70% carbon dioxide emissions reduction is used to 6,000 metric ton per annum. This is the evaporation losses from where we can achieve. And ground mounted is also, we have seen the 250 megawatt power plant already in operation last 2 months before in Andhra Pradesh. That is connected to the grid also. Now, this is some of the things. Apart from that, I don't want to take much of your time because I'm left with only 5 minutes. This is the smart grid. Actually, this is also one of the promising area where we have to pay and where we can see the some of the things. Transform the Indian power sector into a secure, adaptive, sustainable, and digitally enabled ecosystem that provides a reliable and quality energy for all with active participation of stakeholders. Means if you have your solar power, roof mounted solar power of on your house, then you will be also treated as a one of the generator, and you will be adding your power to the grid, and also it is one of the requirement as on date. Now coming to that, what I want to convey this one is we can design, construct, observe, initiate, drive, move, accelerate the world, or the gears of progress, or the future of the nations, and all the engineers, especially electrical engineers. Now it is per tunnel, this is the beginning, and we can achieve what I told, cheapest power and clean power. So this is the tariff. Now we can have even less than 3 rupees power per kilowatt hour. This is the already we are coming up with. Now, apart from this, this is the one dialogue that we can achieve a cleaner, greener, and sustainable energy system through efficient use of earth resource. Thank you, sir. So I'm having left with 2 minutes. So anyone can ask any question, or you can send it to my email ID or my mail mobile number. This is I am free to address all the questions, and even if at all required, you may also send a mail also. I will try my level best to address the queries. So this is all about from my side, sir. Thank you.
Thank you very much, sir, for such an insightful and technical rich session. So participant, if you have any doubt, you can proceed very quickly. Otherwise, sir has suggested you can proceed accordingly.
Good evening, sir. I am from mechanical engineering background, sir. Thus, I want a small query. So suppose if there is any transmission line, high tension transmission line is broken due to any reason. So what is the protocol which is applied after that?
Sir, very interesting question, sir. Transmission, actually, we are having a double circuit. Everywhere, we will operate in very reliable and safe manner. Suppose if I can have any emergency, I have to meet up in time. Means, as you told that some power transmission network collapsed. One tower got collapsed. I'm coming to not the tower. One segment of the in between the two towers, one segment got collapsed. That is single circuit got collapsed. Now, on the other hand, I'm having in the total system network double circuit. Means second network has to handle that much of amount of power. That's why in design point of view, in design only we will take the factor of safety as well as the total capacity of the line to handle in case of emergency. Now your question is, suppose one segment got disconnected or damaged or collapsed, what will happen? So immediately the second line, which is already in service, the load will start flowing through that line. And now what are the protocols? Next question you ask it is, what are the protocols? Now we are having our relay coordination. Means there is almost every thing is operated by the healthy and promising relay coordination. If suppose one circuit got tripped and got disconnected, means we don't know where and how, but the total system will start flowing from another circuit, but it is having its limitation. Means I have to adjust. I have to really look at my relay coordination with sending and receiving end, or point to point, or node to node, in such a fashion that it has to give alarm, first alarm, so it will give alert. And even though after that also, if I unable to understand, then it will give priority. And for the safeguard the equipment, it can take the tripping of the equipment also, because ultimately at the end of the day we need to have our own secure and stable power. So these are some of the protocols that we want to follow. And after that also, post-mortem analysis and pre and post, that is also available through DR, disturbance recorder, where we can have our own information. And some of the things are there that we want to, suppose in a domestic, suppose in 11 kV line in our domestic power got power gone. Okay, well, immediately everyone will tell a power chala gaya. No, not like that. But the operator will take a one shot again without any hesitation. If it stands good, okay. Otherwise, he will not dare to charge the line, because those are the things that in the protocol we have to check. We have to see the relay targets, relay alarms, and all, so that we can conclude what are the things that to be taken care. That SOP is there. We want to follow. We will follow also. Am I clear, sir?
Yes, sir. Thank you, sir.
Okay, sir.
Any
Any-
further question, participants? Otherwise, we'll close the question and answer session. Okay, so I would like to request everyone to please switch on your camera. We have to take the screenshot.
Dr. Rajan, please.
Sir, I'm sharing. Just I want to close it.
Done. Thank you.
Thank you, sir. Thank you. Thanks once again to Dr. Bhomik Saab and all
Thank you.
eminent personalities who joined my session. Thank you. Thank you once again. Thank you, sir.
Thank you, sir. Participants, shortly we will move ahead for technical session 2. So please remain present. Thank you.